Okay, number 24. This one's actually kind of nice because it's already factored out for you so that you know the solutions if you had set it equal to 0, but you can still type it in your calculator to look at the picture. In other words, you see we have 3 x's here. This is an x cubed problem. It's degree 3. Before we go any further, you know things about a degree 3 problem. For example, you know to expect up to 3 minus 1, 2 curves. That's very helpful to us because we're looking at an inequality and we know how many times we're expecting this thing to cross the x-axis. We know it's going to do something probably like that or just the opposite, like that. It could be flatter versions and things like that, like you guys have seen when you have repeating stuff. But let's see. These points of interest will happen at, well, whenever x minus 4 is equal to 0, whenever x minus 5 is equal to 0, and whenever x minus 6 is equal to 0. So these are our boundary points. Whatever equals 0, that's how we get the boundary points of interest for our picture. So I'm getting an x equals, let's see, that's a positive 4 if I add 4 to both sides. Here if I add 5 to both sides, x equals 5. And if I add 6 to both sides, well, I showed you that time, x is equal to 6. So those are my boundary points. Remember, guys, just like with inequalities, or excuse me, just like with quadratics, when you have an inequality, it plays differently. All of a sudden, you're interested in a region, not just a specific number. So all those do for us is it helps us sketch the picture. Now we can actually use our calculator to verify if this thing's going up or down, since it's not very easy to see the a on this function, that leading coefficient. So I'm going to literally just type in parenthesis x minus 4, close parenthesis, open parenthesis, x minus 5, close parenthesis, and the same thing, left open parenthesis, x minus 6, close parenthesis, so that I can see a picture. It's kind of important that you understand both concepts, though, because you want to know kind of what's going on in your picture. It's going up, down, up. So we have something like this. Let's see, it's happening at 4, 5, 6. That's why it's so close on our picture. In fact, I could zoom in, but I feel pretty good about this. It's going up, down, and up. So again, the main goal of this problem is to tell the reader, or whoever's asking the question, when is this function less than 0? Now that we have the picture, we can see that it's below 0 here and here. And of course, this does not include 0. There's no equals sign on my inequality. So my answer would be from negative infinity up until, let's see, the first point, the lowest one's going to be 4, using parentheses, not brackets, because there's no equal to sign. I'll use my bucket to collect all of my answer pieces. And then I'll say, okay, then from here to here, that's a 5 and that's a 6, because I know the 2 points where it's crossing. So between 5 and 6. And those are my solutions. Let me put them up here again on the line. Okay. The last problem we have, number 25, is almost the exact same idea. We still want to look at our pieces. Of course, in order to solve this thing equal to 0, which is the first thing you always do with these, I have two options. I can either say x squared minus 9 equals 0 and then solve for it that way, or I can remember that when I have the difference of perfect squares, it's pretty easy to see it split into 2 pieces anyway. I'll go ahead and split it since a lot of us are visual and like to see it like that. So this is us getting our boundary points, the ones, you know, where it'll cross the x-axis. So here I have x equals, that's a negative 4 since it'll be the opposite, x equals positive 3 since it will be the opposite, and x equals negative 3 again since it will be the opposite. Sketching this, I see it's also a cubic function, excuse me. So let's put this in the calculator to kind of verify the shape of it, since I can't see the a. If we saw the a, it would take 2 seconds to sketch this thing. But we'll type it in our calculator just to be sure. And again, guys, I do not simplify these. I literally type them in the way they are and take a look at the picture. We don't need anything too great. We know what the intersection points are. We know we have a negative 3, a -4, and a +3 happening. So we just need to see kind of the behavior. In other words, we know it's going up, down, and it's going back up. That's enough for us to be able to talk about when is this bigger than 0. And that would be between here and here and up here. That's when it's higher than my x-axis that's a 0. And again, on this one, we will not include any of our values because that's an inequality that does not have an equal sign. In other words, that looks like a -4 to a -3 joined with a 3 to positive infinity. And that's it.